Good morning or afternoon, depending on your location. My name is Peter Graham, Salesforce Practice Leader here at Cervello, and welcome to today's webinar on Extending Salesforce CRM Data Value with Heroku. Joining me today are two other speakers, Abe Pursell, who's Regional Vice President of Global Alliances and Channels at Salesforce, and I'm also joined by Glyn, who is Managing Director of Cervello's EMEA region. Just a little bit of background about Cervello. We are a Salesforce partner. We go to market around three core practice areas. One of those being the CRM practice, which for us is 100% focused on Salesforce. In addition, we have two other practice areas, one around business intelligence and analytics, and then the third area being enterprise performance management, which is solutions that fall within the Office of Finance and CFO. Underlying all that, we help our clients build out what we refer to as their modern data architecture to not only support the growing needs for data, but also connect each of these three areas as an organization. So let's talk a little bit about what we're going to cover today in the webinar. So we're going to address how the Heroku platform can address some of the data challenges that organizations are facing as their data demands grow. We're also going to address how does the technology help accelerate and address some of the consumption demands that the organizations are facing. And we're going to talk about what the construct and foundation of a modern data architecture looks like and how that can support the growth and connectivity the organizations are facing around data. And we're going to do this today through some use cases and reference architectures and how some of our clients and we see leading organizations address some of these challenges that they're facing. At the end, we will do some Q&A, so you can submit your questions through the GoToMeeting chat, and we can address those at the end. So when we step back and think about some of the challenges that organizations are facing with their data, I think one of the big things that we see is that ultimately data is an asset that organizations can really take advantage of. And what we see is a lot of organizations struggling with this. Part of that is due to the fact that they have some legacy technologies, along with skills, methods, and mindsets that just don't address how to manage that data, how to connect that data and truly treat it like an asset. Where we see most organizations that are beating their competition in this area is they have addressed bringing in more modern technologies, platforms, methods, and they've created a bit of a competitive advantage in potentially disrupting their industries. And ultimately, there are better, faster, cheaper ways that organizations can connect their data and solve their data supply problem. So it's Cervello's belief and point of view that with the appropriate architecture and applied technologies, organizations have the ability to leverage that data as a true asset. So having said that, we at Cervello have turned to the Heroku platform to help address these data needs. With that, I'm going to hand it over to Abe, and he's going to provide a little bit of background around the Heroku platform.
Excellent. Thank you so much, Peter. Great to be here today. So first, at a high level, just a quick summary of what Heroku actually is. Heroku is a developer platform as a service that runs entirely on top of AWS. AWS, we feel, gives us tremendous competitive advantage, being the global public cloud leader. And you can see from the diagram here, what we've done at Heroku is be able to layer on a number of value-add features and functionality around AWS that are fully managed. What that does is allow us and our users of Heroku to focus 100% of their time on developer productivity with enterprise controls and security built in. So that means developers will be able to accelerate their productivity, lower the operational complexity, and with that, the overall operational risk. One of the specific features we're going to drill in here on is Heroku Connect, a tool that lets you seamlessly synchronize Salesforce CRM data into environments on Heroku. So we'll go to the next slide. But as a pretense, one of the challenges in context to Salesforce that a lot of customers have had is just the growing amounts of data. Over time, there's more data than ever before. As customers have numerous different environments and CRM usage grows, the amount of data, of course, grows within a CRM environment and other disparate databases. As our customers have more customers, accounts, contacts, and activities from those customers, naturally the data sets grow. And then lastly, of course, over time. So moving forward, every day an organization accumulates more data. And so quite simply, every Salesforce customer needs to be thinking about what is their holistic data strategy to get more value out of their CRM data and be able to extend and augment those systems. Let's go to the next slide. And for us and our customers, this is where we asked ourselves a pretty simple question. What if I had a scalable SQL database and custom compute environment for my Salesforce data? Well, enter Heroku. With Heroku, being a platform as a service, we decided to build and augment CRM with a few core out-of-the-box pieces of functionality. The first is Heroku Connect. Heroku Connect is a tool that allows for seamless synchronization of Salesforce CRM data out of the box, bidirectionally with Salesforce systems and Heroku Postgres, which would be the second pillar. Heroku Postgres, for those not familiar, Postgres is an open source SQL database standard. At Heroku, we manage over 1 million different Postgres databases at enterprise scale. Postgres databases are a great place to store SQL relational data that can scale up to terabytes of data in a very cost-efficient, effective manner. And then third and final, we have the Heroku runtime. And this, of course, is where the real value can happen. This is where customers are able to transform and present data to new users, constituents, integrate with other systems, and of course, even quite simply present back into core CRM as if the data never left via out-of-the-box OData protocol and wrappers. And freeing developers to create this value is with all the common open source languages and frameworks. Of course, at the backbone of this is Heroku Connect, the tool that allows for out-of-the-box bidirectional data sync between Heroku Postgres SQL and Force.com Lightning Connect. So go to the next slide. So with that, at a high level, let's cover what are a couple specific use cases that customers are using Heroku Connect and Salesforce Connect today. The first is the most kind of simple and straightforward, Salesforce data archiving. Next, we have integrating Salesforce with external databases and services. Then we have multi-org data integration. Think of a kind of hub and spoke model. We have advanced BI and reporting. And finally, we have leveraging Heroku for complicated business rules and processes. Think of rules engines, calculators, things that require large amounts of compute to be able to effectively run. On the right-hand side, you'll see a nice diagram outlining a pretty basic standard architecture that's being used to accomplish many of these use cases. And on that, I'm going to pass it back over to Pete, who's going to take us into next level of detail for a few of these use cases. Pete?
Great, thanks, Abe. Yeah, so as Abe mentioned, data archiving is a fairly straightforward and perfect use case for the components, architectural components, technology components that Abe just described. So let me jump into this a little bit, describe it in more detail. So what are some of the drivers for managing and archiving Salesforce data? So the first two here, reducing data storage and addressing performance constraints, are pretty common requests that we see from our clients and customer base as to needing an archiving solution. So over time, as data has grown in their org, either through standard or custom configuration, custom objects, they need to reduce the storage. And that's a pretty common use case. The next two around regulatory requirements and data retention policies. So if you're sitting in a regulated industry such as financial services or healthcare, it might not be so much about reducing storage or managing data. It might be just about I need to meet some retention policy requirement. And then the third, or last, I should say, is thinking about how do we integrate this data beyond use case of just archiving. So how do we integrate the CRM data into other data assets that might exist within my enterprise? So things like a data mart, a data warehouse, or a data lake. And again, so these are all really great use cases that can be addressed to the Heroku platform. So let's build out what the architecture would look like. So as Abe mentioned, we start with Heroku Connect. And so what that's going to give us is this bidirectional synchronization between objects in Salesforce and my CRM to Heroku Postgres. We then wrap that around two core components to address archiving. One is a series of admin interfaces that would live in the Salesforce CRM, where administrators can configure and schedule jobs that would manage the archive data. And then this Cervello archiver engine, which is running in the Heroku platform. And really, this is where a lot of the logic and heavy lifting is being processed in the Heroku instance. As Abe mentioned, we can leverage dynos to scale, and we can use other add-ons that are available to us in the Heroku platform, such in our case, we're utilizing something called RabbitMQ, which is a queuing engine, again, to make this process to be asynchronous. And then finally, there's Salesforce Connect. So as Abe mentioned, we can expose the data from our Heroku Postgres database as an OData endpoint. And what that means is I can still access the data that's been moved off platform inside my Salesforce instance. And so even though I might not persist that data anymore, I can actually still get access to it. So let's walk through what this might look like, and then I'm going to move into a demo and actually see this in action. So imagine if we had a custom object in our Salesforce instance called an audit. This audit might be a master detail child relationship to an account. So over time, we might see that audit object grow. And so we may have 1 million records that grow into this custom object over time. So the first thing we're going to do is we're going to synchronize that object using Heroku Connect. And when we do that, what Heroku Connect is going to do for us is build a Connect table in our Heroku Postgres database. And we don't need to do this ourselves. It's going to manage that for us. From an archiving perspective, then what we're going to do is set up an archived table. And this is think of it as a shadow copy of that Connect table. And what that will do is it will mimic the data structure, keep that in sync, and then we can establish a rule. And that rule might say, archive any audits that are from 2017. And that might move half of those records into that archive version of the table. Once copied over, we can then say, okay, let's delete or remove those records since they're in an archive state. Heroku Connect will then synchronize that deletion operation up to Salesforce and reduce the data storage on the left-hand side of this diagram. And so when we're done, we've obviously reduced the records in Salesforce. And on the right-hand side in the Heroku platform, Postgres, we now have a full set of the original 1 million records split between our Connect table and our archive table. So let me go ahead, I'm going to jump out of this. I'm going to go over to a demo environment, and I'm going to show this exact use case in action. So I'm within Salesforce here, and obviously I'm showing this in Classic. We can definitely run this in Lightning, supporting on both sides. But I'm going to start with looking at an account. And I'm going to go into my Heatley account for those that are Silicon Valley fans. And what I'm going to do is I'm going to scroll down, and I can see on my page layer, I have a series of audit records, actually a fair number of them. I actually have a roll-up field here that tells me I have about 517 of these audit records available. So I'm going to go over to, again, an admin screen that would have been pre-configured. And I'm going to select to archive some set of this data. We'll give this a moment to come up here. And when I archive this, I'm going to decide I want to archive all the audit records that are in 2017. So I have a series of different existing configurations available to me. I can see I've got this one archiving. So I'm going to go ahead and run this. And this says, for any audit records, custom objects, archive anything that's in 2017. So I'll go ahead and run this job. I'm going to warn me, do you want to run this? And what we're actually doing is running an asynchronous process now on the Heroku platform. So independent, I don't need to pay attention to that job, but I actually can go in and view the status of it by looking at this job log. And I can see that bulk archiving job is in progress. Just going to wait here, get a refresh and see when it's done. Should move fairly quickly. And it's completed. And so it did archive about 730 total records. If I go back to the account object itself, and I go back to that same Heatley account, what I can see is that I scroll down, I still have a number of records that are still in my Salesforce environment because these were probably created in a different year from 2017. But I also can see here on my page layout, I have these archived audits. And these are essentially OData, these are external objects being surfaced to me via Salesforce Connect from the Heroku Postgres database as an OData endpoint. And I can also see that my total number of audit records has gone from 517 to 152. So I've reduced the number of records in Salesforce, but I can still access these if I were to click through and look at these records. So that's the use case of archiving. And again, we can unarchive too. And so a common use case is to bring that data back into the Salesforce platform. Okay. So another common question we get here is actually how is this different than using big objects in Salesforce? And so big objects is definitely a useful capability available. I'd say that the primary difference is that it's a use case where you just want to use a static version of the data or persist it off. And there are some other use cases that we address that aren't maybe satisfied through the big objects capability. So unarchiving being one of those. So what are some examples of case studies of our clients where we've implemented this? And I'll quickly walk through these three. The first was around Service Cloud implementation that was about 16 plus years old as an implementation. And they wanted to reduce the data storage out of their case object and all the related child records that are associated with it. So we archived about 35 million records total of cases. Again, had many case child records associated with it. And again, we were trying to improve performance from a service agent perspective and reduce the data storage within Salesforce. The second use case is a home assessment and care management service organization. They had a custom tool that was used in homes to do healthcare assessments. And as you can imagine, that was driving a fairly significant data storage, large data volume on the Salesforce platform. And we archived about 150 million total records. It also supported an archival process. And again, we reduced the data storage on Salesforce quite significantly. And the final one is a nonprofit organization. And again, very similarly, they do a lot of fundraising campaigns. And so they had a significant number of campaign members, 300 million, that we were able to archive and move off platform. So let's move into use case number 2, which is around master data management. So as Abe mentioned, he talked a little bit about multi-org. And this is a good example of a multi-org use case where I've got multiple Salesforce orgs and I need to manage master data between them. So that's a common problem that we see organizations facing is that they have more than one Salesforce org. And through that, they're struggling to keep the master data, such as accounts, contacts, products, or anything, synchronized between those orgs. This issue gets larger as we think beyond the CRM and we start to look at other SaaS applications that we might have in our enterprise, which also relies on that same set of master data. And then ultimately, when we start to think about other downstream implications, such as analytics or data warehousing or data science, not having clean data from a master data perspective can inhibit us to be able to join, merge, or transform that data as needed. So why is master data important? Well, it's a key lever from both an operations perspective all the way through to an analytics perspective. And master data comes in many different flavors that organizations need to consider. The first being, what is the golden record? So what is the core reference data that all other systems rely on? So how do we store, maintain, persist that data, and then connect it where appropriate? So again, there are many domains of master data, and having golden records, customer being one of the primary ones, but there are many, many others. Beyond the golden record, there are other things that need to be considered, such as, well, how do I want to structure this data, and what's the relationships that this data might have? And so thinking about such a customer hierarchy as an example is another example of the type of master data that needs to be maintained and shared across the organization. Networks is another kind. So thinking about things like, well, what are the relationships between these records? So customer might be one domain, but supplier could be another, and we know there might be a relationship. We also can look beyond that into social areas, social graphs. There are also networks. And then finally, there's reference data, which is data that might be both internal, but maybe also external. So things like currency conversion and currency rates are a common set of reference data that organizations need to maintain and share. So putting all this together and putting it in context, it's clear that master data has got both breadth and depth to it within an organization. That's why it's critical. So let's walk through a use case here of what happens when master data is not managed. So if I start with a simple action of I need to update a customer account in a CRM as a business user, that might need to go to a Salesforce admin to then update the subsequent Salesforce orgs that admin might be maintaining. And so they're making that change in more than one place. Those systems might need to then be propagated to maybe an IT admin who is maintaining a series of ERP applications. So any of the other operational systems that may depend on that. Moving beyond that, we can start to think about other database platforms. So we may have a database admin who's managing a series of relational databases and needs to be aware of that change. And then we may have roles like data scientists who are maintaining their own big data platforms. So things like Hadoop, Spark for processing. And we might also have a BI admin who's maintaining a series of analytic platforms that change is also critical and important to. And so again, we have a series of database and analytics systems that are dependent on that change. And as you can imagine, there's a series of issues or challenges that we see through this use case. So things like there's obviously an opportunity for many errors to be propagated through the system. There's no auditing or rollback capabilities, lack of governance, and clearly the timeliness of this change is lagging or latent. So if we were to imagine what this might look like in a governed environment, and we use Heroku and build out a master data management solution within it, what that change might look like. Well, it starts with, why don't I allow my business user to make that change directly in the CRM? And that CRM, using Heroku Connect and some of the other Heroku technologies, could synchronize back into a hub. And this hub could then synchronize to other subscribing Salesforce environments. Again, using Heroku Connect to synchronize all those changes. I can then look beyond that, and I can think about in a publish and a subscriber model, I can have consumers who follow that change and can consume that change within their subsequent systems. So again, the ERP. And again, all the other database and analytic systems could also be considered subscribers to that same data. And so what this gives us is some more robust capabilities from an MDM perspective, some more real-time synchronization, and again, an architectural model that allows us to scale. So what does that look like? And let's go a little bit deeper into the Heroku architecture here and talk about this use case. So as I mentioned, it starts with, let's leverage Heroku Connect to bidirectionally synchronize our Salesforce or CRM data, and specifically our master data, back into our Heroku app. In that Heroku app is where our MDM functionality is going to take place, where we can address some of the needs around profiling, data matching, and ultimately synchronization. We can then take into this architecture Heroku Kafka. And so Heroku Kafka is going to allow us to then publish along a series of topics. So topics can be a topic related to customer changes. And then any subscriber or consumer can then have their own applications that read off of that Kafka stream, and then synchronize those changes into their consumer systems. So again, the relational database, the big data platforms, or the analytic platforms. And so with this architecture, again, we've got scale, and we've got a more modern architecture to support an MDM hub. So with that, let me hand this over now to Glyn, and Glyn's going to talk a little bit about a more broader use case around what does a modern data architecture look like within an organization. Glyn?
Okay, thanks, Pete. So I want to talk through this third use case of using data from a broader perspective within organizations and what it means to have a modern data architecture and the role that Heroku, Postgres can specifically play with it within that architecture. So, Abe mentioned, an explosion of data sort of within Salesforce. I think, outside of Salesforce, we're also seeing a general explosion in the demand for information across the organization. I mean, traditionally, you would see a lot of consumption of information for internal, external reporting from areas like the Office of Finance. But, these days, with the advances in the different types of data that's more readily available and the maturity of the types of analysis and reporting that organizations want to do, you're seeing a broader set of demands. So whether it be getting to know our customer better, getting a 360 point of view of the customer, whether it's understanding our products and the profitability of products, or how to leverage some of these new data types that are out there, whether it be the Internet of Things with IoT digital data or e-commerce data, for example. Different data types that maybe traditionally a few years ago weren't as readily available, but are now readily available, and coupled with the increases in the maturity of business stakeholders, we're seeing a greater demand for information. So to support that demand, we need to talk about what are some of those critical capabilities that an organization needs to have or develop. And this is where we start to think about architectures or modern data architectures to support that. So, the business demand is often, probably covers three main areas in terms of what we're trying to do within the business or how we're trying to activate the business. Understanding just what is going on within the performance of our business. So are we able to measure how we are performing as an organization? And this is typically done through, reporting our results through basic reporting, providing basic insights. Then the demand is there in terms of, understanding how we've reported, so that content that we reported on. So can we diagnose, why in fact are we performing as we're reporting, or why are we underperforming? How do we understand what is driving that? What are the root causes? Then, once we can measure and understand, what are some of the decisions that we can make to maybe change the behavior of the organization, either increase our business performance and so forth. And that's really thinking about, sort of driver-based modeling, for example. If I tweak certain drivers, what is the ultimate impact of that? What are decisions that I now need to make as a result to affect the change within our organizations? So those sort of business processes are supported by capabilities from a technical perspective in terms of both how I might consume that information and then how I might present that information through connecting the data required. So, measuring is, as I mentioned earlier, typically done through our typical KPI reporting, through our standardized reporting, whether it be internal or external reports, very well-defined data, typically maybe developed and pushed out through our IT organization. Then from being able to understand and interact with that data, we're looking at more self-service type analytics. So our ability to interact with that data, so drill down, drill across, etc., but also do some ad hoc reporting, some ad hoc analysis driven by the functional or business need. Then there's also a maturing need to do data discovery. So maybe, my existing reports, or my dashboards tell me how we're performing based on preconceived ideas around our business and how we may want to report on it. But what about getting additional insights from the data within the organization? As I talked about, there's a lot explosion of data within organizations. Well, maybe I want to be able to test, different hypotheses around our business. How can I do that? How can I do some discovery work? So data discovery tools are required to sort of open up the data assets that we have. And then, can I apply some more advanced sort of learning capabilities from a data science perspective? So this is where we get into more predictive understanding, running models, so maybe machine learning, AI type capabilities. So these sort of technical capabilities are absolutely dependent on the ability to make data readily available. And when we think about our data and we look along the lower stripe here from our data sources perspective, not only are we dealing with internal data, but also external data and the opportunities around that. So different types of data, different volumes of data, different sources of data. And I want to bring that into my organization and connect that in some way, whether it be in more of a governed manner, where it's controlled in terms of the quality of the data, the definitions of our data, the master data, as Pete spoke about within one of our previous use cases, or from maybe a loosely governed perspective. We're not quite sure how we're going to use this data, but we want to make it available for us to run some of this data discovery or data science capabilities. So an organization needs to start thinking about, well, how can I handle these scenarios? How can I start to think about the architecture to support this and the requisite tools and technologies in place? So, how do we deliver those capabilities within an organization? Well, we like to think of it as there's really three pillars, and we're going to focus on one of those pillars, which is the modern data architecture. But the other two pillars are, well, how am I organized, from an organization perspective, a people and process perspective? So not just from an internal IT perspective, do I have the requisite skills, to enable these new data assets, but do we have the right methodologies in place? And then from a business perspective, do we have the right subject matter expertise skills? Do we have the right center of excellences? Do we have the right governance processes in place? So an organization needs to think about those from a delivery perspective. Then there's the actual physical execution model itself, meaning how do I actually execute on this vision? So it's all very well talking about architecture and tools and technologies, but how do we actually, meet the demand of the business in terms of building out solutions? So how do we execute upon projects? How do we execute upon programs and so forth? The third one is, the technology focus is the modern data architecture. And so, we've looked at it from a business perspective, but what does it mean from a technical perspective and the technologies to support that? So we're going to focus just a little bit in the remaining time on that aspect. So similar to the business point of view, we have a technical point of view around the modern data architecture. So again, let's go bottom up from this slide's perspective. So data source layer, meaning, what are these data types that we have out there? What are the opportunities around these different data types? So as I said, we have these traditional and non-traditional data types. Traditional being maybe those that we're comfortable with in terms of systems that we use to run our business, so our ERP systems, our CRM system, etc. Things that really sort of drive and support business process within an organization, pretty standard in terms of most organizations. Those sort of systems that help keep the lights on in terms of your business. And then we have the non-traditional, as we said. Maybe this is IoT data, social media data, unstructured, structured data that we need to sort of consume into this sort of data management layer. So the modern data architecture needs to be able to deal with the volume of data, so serious sort of amounts of data and data growth that we can expect with lots of these new types of data. So an architecture or a data management layer that can deal with the volume and has the ability to scale near time, scale real time, and so forth. Low cost methodology around that as well. Dealing with the different varieties of data, we touched on that. So it supports both structured, unstructured, content such as JSON, video, IoT data. Velocity of data is very important. Business user community now are somewhat, their expectations around getting hold of data and the performance of data is what we call in sort of Google time or Facebook time, almost instantaneous interactions with that data. So how can I deal with that velocity, and the demands of the velocity of data? So the data latency, if you like. So whether we're doing batch or real-time streaming to ultimately enable this sort of quicker decision-making or insights in the business. And then our ability to, as I touched on, from a governed and loosely governed perspective, how do we do that? And how do we make that available in very much a similarly scalable solution that is modular and has a level of elasticity to allow us to grow as the business demands grow and the data demands within the organization grows. And that's what this sort of business ready layer is making sure that we have that data in a more connected, more governed fashion that allows for the different types of data consumption to be performed in a very much highly performative, integrated, and extensible manner. The user layer is, touches on the different tools and technologies that are required to support that. So obviously, best in class might be our ability to leverage multiple tools. Not all tools are purpose for all jobs. So what you typically will see is maybe a combination of tools. So whether the tools that your data scientists or your citizen data scientists may use versus executives or line managers to interact with the data may be quite different. So the next slide sort of starts to put more of a physical perspective to it from a tools and technology. Here's an example of where we're layering on Heroku Postgres with some of the AWS big data lake technology stack. So again, what does this mean from a physical perspective? From a data sourcing perspective, we need to think about methods of ingesting that data into our data management architecture. So whether we're dealing with APIs, secure FTP, direct database imports, or simple sort of importing of files. There's different methodologies depending upon the different data types that we're looking to acquire into our data architecture. Then from a data management layer perspective, excuse me, we need to think about an extensible, scalable data lake foundation that allows us to put the processing of data within the platform, to really leverage the platform to do some of that conforming and transformation that we want to do. Then, there is the business ready layer, and that's where we can think of what the role of Heroku Postgres in terms of, having a database technology which is highly performative for the consumption of data by the users, by our user layer. So, where we might think, in the previous examples of Postgres playing a role as an application database, whether it be supporting my master data management or my archiving, it in itself can be a component of our modern data architecture at near the presentation layer. So in fact, we could have extended this slide by showing Heroku as a Postgres database as a data source that we may be pulling data in. So in Pete's example, where I might be managing our master data is very important in our data lake and in our reporting and analytics. So that may be a source into our overall data lake architecture. And then it, as a database technology, can be there to be as a highly performative source where we've structured that data, maybe preconceived structures to enable the highly performative insight and analytics through the semantic layer. Here we see the semantic layer, various tools, whether it be Einstein or R or Anaplan for EPM. These are just different tools or different types of technologies that the user community may be doing to consume that data. So just in summary, obviously, there's a broader story around the usage of information within an organization. Challenges organizations are faced today as how do we deal with this explosion of data, the different types of data types, how do we connect that data, and how do we do it in a performative architecture? This requires what we believe is more of a modern data architecture point of view. And then what are the requisite technologies and their role within that architecture to ultimately deliver to our business and enable the business in their decision-making and insight processes. So at this point, given the time, I'd like to hand back to Pete, who Pete will bring us to the finish line. Thanks, Pete.
Great. Thanks, Glyn. So before we wrap up and move into Q&A, let's talk a little bit about some calls to action here and how you can get engaged. So how can Cervello help, and what are some of the areas that we can help with? So let's start with, if you are having or facing challenges around large data growth in your Salesforce platform, obviously, as we talked about from an archiving on Heroku perspective, perfect use case. So we can schedule a discovery call, have us do a more in-depth deep dive into the architecture and scope out what an implementation looks like. if you are dealing with multiple Salesforce orgs that you don't plan on consolidating, but you do need to synchronize master data, such as accounts or contacts between those orgs, we can set up an introductory call, talk about your current state architecture, and talk about what an MDM implementation roadmap would look like on the Heroku platform. And then finally, if you're struggling with a more broad architecture and the ability to satisfy some of the data and analytic demands that your organization is facing, we typically would recommend starting with an enterprise modern data architecture assessment with a Cervello team and experts to do that. So definitely multiple ways that we can get engaged. As both my contact information along with Glyn's is provided here, so we'd be happy to schedule a call on any one of these topics, or you could coordinate through your Salesforce account team as necessary. We can set up an introductory call. So with that, let's move into some Q&A. There are a few questions that have come across, and we'll wrap up on these, and then we'll close out the webinar. So first question came up around the Heroku Archiver. I showed that in classic mode, classic UI. So is it Lightning enabled? And the answer is yes. So we had just displayed it in classic. I could have easily gone up and flipped it over to Lightning, and everything you would have seen in that demo would have been the same in the Lightning interface. Next question was around how do you expose objects through an OData wrapper to external affiliate systems? What connectors can be used? So there's a couple of things there to mention. So Heroku Connect will give you the ability to expose Heroku Postgres as an OData endpoint. And so any connector, OData supported connector, can connect to that data source. So an example of a connector that can be used would be Salesforce Connect. Salesforce Connect allows you to create external objects. Those external objects can then connect to an OData endpoint, which in this case in the demo I showed was Heroku Postgres. Next question, how does Heroku Postgres consume any API calls? I'm going to change this question, I think. So I think the question is more, how does Heroku Connect consume it? Does it consume any API calls? No, it does not. It's a Salesforce product. It's whitelisted, and so therefore it's a great use case where you're not going to consume any of your daily limits in your 24-hour period or rolling window around your API calls. So if we think about synchronizing 100 million records between an object in Salesforce to Heroku Postgres, that will not count against those daily API calls, which is again another reason why we, from an archiving perspective, as an example, it's a great use case to not impact that. A couple questions about MDM. So, do you have a separate MDM tool? Is there a specific MDM software provided in the Heroku stack? So the answer is no. So what we've built out here is a custom solution. And so if you think about the use cases of, do I buy something or do I build something, we can build. And we've addressed that through a framework of an MDM solution to connect all the parts using the software on the Heroku platform to do that, but also gives you the ability to extend that model where applicable to your own specific use case. Okay, great. So that was the last question. So with that, we're going to wrap up the webinar. We will be distributing the recording out to folks. So, and as I mentioned, if there is any need to reach out to any one of us today, our contact information is provided. So with that, we'll close out the webinar. Thanks, everyone. Have a great day.